Here we go, guys. Answers to GCSE Maths. Non-calc first for you. Okay, so here's the second set of questions I've put together on a sheet for you. This is about 3 weeks now before the exam, and so really do try and make sure you can do most of these basic things. Can't guarantee they're coming up, but who knows. Here we go. First of all, the set of questions, and then I'll give you the answers and talk through this one. Okay, so here are the answers then to, first of all, the non-calc paper. See how you go. First off, some algebra then. First of all, brackets. Often asked this one, so let's make sure we can do it. So the brackets come like so, and I always put loops on mine to show that this is all done by multiply. So we're multiplying here. 3 1s, 3 2s, and so on. So 3 1s are 3. 3 2s are minus 6, don't forget the sign. Minus 2 times p, minus 2p. 2 minuses, often asked here, what's the signs? 2 minuses make a plus. Signs the same, plus. 2 4s are 8. And then families, join together the families. What have we got? We've got 3 and 8, making 11, and then minus 6, minus 2. Remember I say I'm owing mum, and I'm owing mum again, so owe mum 6, owe mum 2, owe mum 8. Next one. We have here 3x, x minus 5. 3x times x is 3x squared. Don't forget the squared. 3x times 5, minus 15. Don't forget the x here. This is the important thing. Remember, you're still timesing at this point. The next one, fairly simple one, but again, make sure it's right. The numbers first. 4 3s are 12. And you add the powers a and a2. Don't forget there's a missing 1 there, so you get a3. Then a divide one. 12x squared y over 3x y squared. Cancel the 3 and the 12, the numbers, making a 4. And then x and x squared, you're left with an x. You're taking away powers there, remember. 2 take 1 is 1. And y squared, this time the bigger one is down the bottom, so I leave the y down the bottom. And so altogether I've got 4x on the top, and I've got just plain y on the bottom. There we have the answer. You could do it by powers. The 4 again, x2 and x1 is x1, and on the bottom 1 take away 2 is minus 1. Another little favourite, simple, a minus power means 1 over it, so 1 over 8. In this case to the power 1, which is simply 1 over 8. 49 to the half means a square root. Got to learn this. The power half means square root. If it's a third, it would be cube root. If it's a quarter, it would be fourth root. This is square root. Square root of 49, answer 7. And this horror, okay, don't be put off by it. It's quite workable, no problem really at all. The minus means 1 over. So 1 over 64 to the 5/6 as it was. Now, this 5/6 means the 6th root, and this number will always be a nice one. It'll either be 2, 3, or 4. So what makes 64 6 times? The answer is 2. 2 times 2 times 2 times 2 times 2 times 2, etc. And so it's 2, and then it's still, because of that 5 there, it's still raised to the power 5. So 2 to the power 5. And what's 2 to the power 5? It's 2 times 2 times 2 times 2 times 2, 5 of them, making 32. 2 2s are 4, 2s are 8, 2s are 16, 2s are 32. Sorry, it's rushed, but there we go. Okay, on to another favourite. Anything to the power 0 is 1. Get that wrong, shoot ya. anything to the power naught is 1. We all know that, hopefully. Those who are new readers learn that one, that's often there. Okay, a FOIL with a bit of a difference, but with a 2 on the front. Don't forget, 2x times x is 2x squared. I'm multiplying. Remember this, two things next to each other means you are multiplying. So, 2x times x is 2x squared. And the outer pair, 2x times 4 is 8x. The inner pair, minus 1 times x is minus x. And the last pair, minus 1 times 4. 4 ones, don't forget, you're still timesing, is 4, not 5 or 3. And then the signs there are different, and so it's minus. Then families, that stays as it is. These two together, 8 take 1 is 7. You've got 8 and you owe mum 1, so it's 7 minus 4. Okay, then on to this one. Difference of two squares, factorising, back to front this one now. What we've got here is a square, and so you get plus and minus the square. X minus 8, x plus 8. This one, similar, except first of all, you notice that there is a 4 outside, so 4 brackets, x squared minus 9, because when I do that and that, I get 4x squared and I get 36. Okay, the 4 is common. Then, this is like this one was. Okay, x squared minus 9, so it's difference of two squares, x plus 3, x minus 3. So the 4 stays outside, x plus 3, x minus 3. Then a straightforward factorise. Lots goes on here, but hopefully you are getting aware of this now. How do I do this? Right, first of all you spot there are 3 things, so I get 2 brackets. There they are. X at the front of each of them. Now, next you look at the 35 and say, how does that 35 come? It comes by timesing 35 and 1 or 5 and 7. However many other pairs there are. In this case, that's it. Next, I look at that sign. That one, if that's minus, these are different. If that's plus, these are the same. In this case, they are different in the bracket. Then I look at this one, and I try and find out which is the larger of the numbers I've chosen. I've chosen 7 and 5 because that makes 2. So 7 and 5 makes 2 when I take away, and so I put the minus on the larger number. Minus 7 plus 5, and there's my answer. And then the last one is a real nasty really, but again you can do it if you really give it a go. You spot that there is a 2 on the front, so it's still the 2 brackets, but 2x goes on the front and x there. And then what have you got? You've got 15. 15 is 15 and 1, 5 and 3. And now, instead of just plonking them in, I've actually got to do all of the combinations to see what's going on. So I do 15 and 1, 1 and 15, 3 and 5, 5 and 3. And I work through each of them to see what's going on. So if I do 15 and 1, I get 15 and 2, no good. That doesn't give me 7. I try it the other way around, 1 and 15. If I do that, I get 1 and 30. That doesn't give me it either. Now I try the 5 and the 3. So 5x and 6x. 5 and 6 is 11, no good. Last way round, often is the case unfortunately, 3x there, and 5 2 is 10. And I've got 3 and 10, and hey presto, there's the 7 I want. So it's that way round, 3 and 5. And then finally remember, the minus sign tells me that these are different, and the larger combination gives me 7. So the larger combination gives me the 10 there, and so the 10 has to be positive, so the plus has to go on there, and the minus goes there. Fractions next. 17 20ths plus 4 20ths. When the pizzas, as I call them, are the same, you just add. So not the bottoms, the pizza stays the same, ham and pineapple or whatever. This is 17 plus 4, 21, ham and pineapple. So 21 20ths. This is top heavy, so how many 20s in 21? 1 whole 1, remainder 1. 1 what? 1 20th, 1 ham and pineapple. Just think pizza and you'll get that right. Next, a double fraction mixed numbers. Add the numbers together, 2 and 5, 7. Now put the others separately as what I call my cross method. My cross method is these two here and here. What do? I multiply the bottom, 20. I go this way first, 4 3s are 12, and this way second, 5 1s are 5, giving me 12 and 5, 17, answer 7 and 17/20. See that again? I do the whole numbers, 7, I make my cross there, and then I go 4 3s are 12 first, 5 1s are 5 second. Add them up, and off we go. Same for take away. Same method, identical, whole numbers. 6 take 2, 4. Cross method, third minus 3/4. Then I go bottom first, 4 3s are 12. Left second, 4 1s are 4. Must be that one first. That one first. Then 3 3s rather are 9. 4 take 9. This is, you've got 4 and you owe mum 9, and so you owe mum 5. 4 minus 5/12. And then this one, slightly different again. This is 4 big pizzas. I start eating a bit of a pizza, so I've got 3 big ones left now. And here, I've eaten 5 bits of my ham and pineapple. How many bits of my ham and pineapple are left? 7 bits are left of my 12. 5 out of 12 is 7. That's where that number comes from. Next, I have a divide. This multiplication and division has to be done by top-heavy. Top-heavy is where you multiply these two numbers together and add them. 4 8s, 32, and 3, 35. There it is, 35 over 4. Same again. 5 1s, 5, and the 2, 7. So you multiply there and add the top one. Multiply there, add the top one. That's top-heavy. Once I've done that, for division, the rule, I'm afraid, is you've got to learn to change it to times and flip it. So you turn this one upside down, 5 over 7. Then you cancel. How many 7s in 35? 1 into 35 goes 5. That's all I can do. I cannot cancel top and top. I can only cancel and pair on the top and bottom, that way, or that way, or that way, or that way. So I've got 25 left. Look, 5 5s are 25. 4 times 1, 4. Making a final total of 6 1/4. Because, how many 4s in 25? Answer 6 whole ones, and remainder 1. 1 what? 1 big pizza. This pizza is quarters. 6 1/4. There's your fraction stuff. Okay, on to a bit of geometry now, but it's actually geometry with a difference, because you've got different things to sort of worry about. First of all, if you have a picture which has got these lines, these parallels on, then they are going to be asking you about corresponding interior or alternate angles. And then something else to do with triangles, straight lines, 180s, etc. This one, look, has got isosceles written all over it. And isosceles, you should know, means that these two, the ones opposite the angles there and there, are the same. Right, how do we get on with this one then? First of all, this one up here wasn't labelled on the picture. You do. Put another letter on there. I've called it X. Now, X is 49 because of the Z shape. Can you see the Z shape there, look? Should have been taught that this is the old alternate angle. So X is 49 alternate. You must give that reason in the exam. Okay? Don't leave the reason out. The number and the reason is all important. That's 49. Now that I know that's 49, the triangle has got 180 minus 49 left, which is 131. So these two are going to share 131. So I divide it by 2, and I get 65 and a half. If you can't divide by 2 in your head, here's a little bus stop I always do. 131. You write down 2s into 13 goes 6. 6 2s are 12, remainder 1. Little 1 tick in there, look. 2s into 12 go 5, remainder 1. There's a remainder 1 there, and that 1 is that 1 there. 65 and a half. Okay, different sort of question again now with some algebra. A parallelogram, and it says these two are the same. Well, if these two are the same, you just say exactly that. 5x plus 2, that one, is equal to x plus 14, this one. So these two are the same. So you make it an equation. This is one of those equations which I do by swapping opposites. What's going on? This x I move opposite. It's plus at the moment, so over there it becomes minus. This 2 over here, I don't want there, I want over here. So I move it opposite minus 2. Now do what it says. 5 take 1 is 4x. 14 takes 2 is 12. What's the 4 doing? It's multiplying, so I divide by 4, answer 3. I always teach my group to divide by 4 by putting both of them over 4 like that, cancelling that out, and there's the 4s in 12 go 3. Hardly read that, sorry, it's a bit crowded. There we go. This one, you were asked to find y. Well, again, what I've got here is that these two, okay, x plus 50, 2x minus 10, okay, and this one makes 180. So, if I know that this is a straight line here, then that's 180, so that in there is 180 minus y. Just think, if that was 20, y would be 160. And so the other way around, if this was 160, this would be 180 minus that, so that would be 20. So I've then just made an equation by adding all those together, and they make a triangle which is worth 180. Move it all around, you get x plus 2x is 3x, 50 minus 10 is 40, and move the y over the other side, and there it is. If I want to find out what the actual values are, then in this particular triangle, what I've got is isosceles again. So 3x minus 20 is x plus 50, and this is the same as this one. Move the x over, so it's plus, becomes minus, so 3x take away x is 2x. Move the 20 over, it was minus, over the other side becomes plus. Plus 20 and 50, 70. 2x equals 70, halve it, divide by 2, and so x is 35. Next is substitution. The question will say evaluate or find the value of. They give you some numbers and you plug them in. So write it down, okay, that's what was on the question, and then substitute exactly as you see. P is minus 10, minus 2 squared, 3. Take the bracket away, minus 10, minus is all I've got there, and then these 2 squared is 4, always do brackets first, and then what have I got? Still the minus 10. Now this lot together, 2 4s are 8, 8 3s, 24. Owe mum 10, owe mum 24, I owe her 34. Owe her 34. Next, same again, 3, etc. B squared, 2 squared, minus 2, 2 minus 3 this time, make sure, and a minus 4, look, there. So what have I got altogether? I've got 4, 2 squared, and then I've got, my goodness, all this lot together. I've got a minus, a minus, a minus. So a minus and a minus is a plus, times another minus is a minus. 2 2s are 4, 3s are 12, 4s are 48. There's my sum. I've got 4, I owe 48, answer, I owe 44. There's my value. On to a bit of standard form. Okay, this you'd see the multiply, so everything can multiply in order. 6 7s I do first, are 42. 6 7s first are 42. 10 3 and 10 5, 10 8. But here notice I'm not standard yet, so I've got to move that back to there, and so 4.2, but I've moved that back, this one's got to go forward, so 10 8 becomes 10 9. 4.2 times 10 9. Whereas if it's adding, or for that matter subtracting, you have to make them normal. 6 times 10 cubed is 6,000. 7 times 10 5 is 7 with 5 noughts on it. There they are. Add those up properly. You put the 6,000 there, look, and you get 706,000 when you add them together. Be careful of the noughts there. And then, if I want to make that into standard form, 7.06 times 10 to the, now I'm there, 1, 2, 3, 4, 5, 10 to the 5. This one, if the rectangle has opposite sides equal, there they are, that equals that. Same as we were doing earlier on again, it's one of these, crossing, crossing, off we go. 6 take this one, 6x takes x, minus 3, add on the other side, there it is, so 6 take 1 is 5, 15 minus 3 is 18, 5x is 18, divide by 5 at that point, So x is 18 over 5. What's that? How many 5s in 18? 5. Ooh, he's got it wrong. 3 and 3/5. 5s into 18 goes 3. 5s are 15. And 3 is 18. And then finally, okay, this figure. I haven't done this for a bit. This is a circle with something inside it. Now, either they ask circles with pi r squared and pi d, or they do this, which is one of the 7 you're supposed to know. This one is the cyclic quadrilateral. The quadrilateral sits on the circle, and what's true about this is these two, or for that matter those two, these two are up to 180. So you add them together, 2x plus 10, 3x plus 20 is 180. Do your stuff, 2x and 3x, 5x, 10 and 20, 30 is 180. Opposite, as usual, minus 30. 5x is 150. Divide by 5, answer x is 30. Question 6. And this is one where they ask you to draw a graph for a line. We know it's a line because it has no x squareds or cubes. It is just pure x's and y's and numbers. This particular question, they cleverly just gave you the axes here, which is the set of x values you use. So I now draw out a table. Sometimes they give this question with part table done. This time they didn't, and so we write the x values. There they all are. Then what I do, remember, is I work this out separately. Some people can work them out in their head. I don't. I do it separately. So I write this separately, 2x plus 1, as 2 columns. I now work out the 2x row. So 2x is 2 of these. 2 minus 3 is minus 6. 2 of those, minus 4, and so on. Then the 1 is unaffected by anything. So 1's across the bottom. And then these two together make y, so I add them together. Minus 6 and 1, minus 5. Minus 4 and 1, minus 3. Minus 2 and 1, blah, blah, Okay? Then you plot on the graph x against y. So minus 3 against minus 5. On the graph paper, if you've got graph paper, would be down here somewhere, where that's minus 5, so it starts off down there. Next one, minus 2, minus 3, would be minus 2 about there. Next one, minus 1, 1 would be about there. Next one, 0, 1 would be about there, and so on. And then you draw, don't forget, the line in. Should be a straight line. All these equations will have a straight line. If it's a plus slope, remember that's the slope there, it slopes this way. If that number there in front of the x had been minus, it would have gone the other way. Okay. Next. A vector question. Marks in the offing here. Some difficult bits in there, but see how you go. First of all, they ask for OX. OX, nose to tail, remember. OX is this, so I go there and there. OB and BX. This time they've actually got them going the same way, so it's B plus A. AX next is this one. Now AX is going to be AO plus OB plus BX, all the way around. You could go to OX if you wanted to, because you've got that there, but I've gone the whole way around. This, again, is AO minus 3A plus B plus A. Now look at the apples. You've got minus 3, you owe mum 3. You've got 1, so you owe mum 2 apples, look, and you've got B there. The order of that doesn't matter, minus 2A plus B, or B minus 2A. And then finally, OT they've asked for. So OT, I've decided to go from OB, BX, XT, or I could go OX, XT. Let's do OX, XT, actually. OX is B plus A. Just found it. OX is B plus A. And then XT is 3/4 of. Look, 3 and 1, 4. So 3/4, that's 3 out of 4. 3/4 of this thing, and 3/4 of XA. Well, XA we just found, except we were going the wrong way. So if XA is what we want, it's the opposite of that. In other words, plus 2A, look, minus b, the opposite way around to that. So we get that so far. Now, it gets complicated now at this point. What we got? Minus b plus a. Now, 3/4 of 2 is 6/4. You just multiply the tops. 3 2's 6a over 4 minus 3b over 4. Minus 3/4 of b. And then finally, what do I do now? Well, look, minus b is actually 4 over 4b. So what I've got is 4 over 4 and 6 over 4. Okay. What have I got there? Minus 4 over 4b. And the a is 4 over 4a as well. So a comes out as 10 over 4. 6 over 4, 10 over 4. And the b is minus 4 minus 3, so that's minus 7 over 4b. And then finally, for real aficionados, here we go. You take the 4 outside, and you are left with 10a minus 7b inside. And then the question which is often asked on this is what we found parallel to something? Parallel means the vector, this bit, has got to be identical to whatever they're asking. Now, bx was plane A. And look what we got, that horror. So there is no way these two are parallel. But if this had just been, say, 5a, then it would have been parallel to plane A, and that's what you say. And you would have said it was 5 times longer. Okay, question 8. A cylinder, and we're asked to show its volume. Now, again, please, please, please write this down. Volume is the area of the end times the length. It's on page 2 of the answer book. Yeah, it's the sheet, the formula sheet you've got, except it looks like this usually, a squiggly bit, remember, with a bit on the end. Same thing. This is a cylinder. So the area of the end is pi r squared. Now, they've caught you here. They've given the length as 10. So that means the radius from the middle r is 5. There's the first catch. So watch it. Area is pi r squared. Okay, cherry pies are delicious, cherry pies are delicious, cherry pies are delicious, and apple pies are too, apple pies are too. So, what you've got here is pi 5 squared, 25 times pi. Okay, and then the volume, therefore, is the area, 25 pi, times, how long is it? 40, so there it is. And then 1,000 times pi is my answer. If it was on the calculator paper, oh, this is non-calc, so leave that as pi in your answer. They do sometimes do this with questions, leaving pi in your answer. Secondly, we've got a fraction of a circle. Now again, this looks horrendous, but it's not. If it's a fraction of a circle, you take the fraction. You know what the circle is, it's 360. So, this is 72 of 360 of it, and cancel that down. 72 and 360 is a fifth. And the circle, here we go again, the area is apple pies are 2 pi r squared. So, we've got pi r squared, pi 12 squared this time. 12 is the radius this time. So, 144 pi divided by 5. Leave that as my answer. Number 9. Again, another bit of a monster, but not so bad. The volume of a cone is pi r squared h with a third outside. On the sheet it is again. Just look for it. Write that down first, and then do what it says. A third pi r, this time, is 3r. So there it is. 3r squared h. What's 3r? It's 9r squared. And then I've cancelled. 3's into 9 go 3. So what's left here is pi 3. Look, there it is, pi 3 r squared h. Dum. The sphere volume is 4/3 pi r cubed. Again, on the sheet. So the sphere is 4/3 pi r cubed. But this time, the r is 4r. There it is. So I've got 4/3 pi 4r cubed, which is 64. 4 times 4 times 4, 64 r cubed. Now, they've said the volumes are equal. Even if you get this far and you can't get any further, write these two statements down and you're in business. So, the volume of the cone, 3 pi r squared h, there it is equal to what I just found here, 4/3 pi 64 r cubed. Monster, isn't it? But there you go. And now, finally, what do? I want h. Well, look, this is multiplying, so I divide by it. So I put 3 pi r squared there, and I put it there, 3 pi r squared there. Now I cancel, and that's all gone, and the pi's have gone there, 3 hasn't, r squared has, and with r, and so I'm left with 4/3 of 64r. I think I missed out a 3 there, did I not? There's a 3 there when I did this. I've got a 3, 4/3, and a 3 there. So I've missed it up. That is a 9, so that should be a 9. So that is no longer correct. Oops. Okay, on to the other bit of geometry now. No angles mentioned at all, but they tell us we've got a pentagon of 5 sides. So the outside, the exterior angle, is always 360 divided by that number. Okay, 5 sides would be 5, 6 sides would be 6, and so on. So 5s into 360 go 72. Okay, if you can't do that, then 5s into 360, 5s into 36 go 7 5s are 35, remainder 1, 5s into 10 go 2, 72. It is there. So the interior angle is 180 minus that, because the interior is 180 minus the exterior. So we've got 108. So that one in there, okay, is now 108, we know. Okay, then the square, of course, is 90. So if the square is 90, we add the 108 and the 90 together. There's a 90 there, look. So we add those two together and get 198, and then take that away from 360 to get the answer 162. Okay, now estimates. The thing to remember here is, apart from rounding to whole numbers, is if they give you a decimal between 0 and 1, then you must make it into a simple fraction, like quarters or tenths or whatever. So, looking here, look, 0.25 and 0.89 is 0.3 and 0.9, but that's 3 tenths and 9 tenths. Pizzas again, so that's 12 tenths. 12 squared is 144, 10 squared is 100, and so move it back 2 places, 1.44. But you have to do it in that sort of order. More importantly, here's another one where that really comes into its own. Often asked, again with the decimal you see underneath, you'll see why in a sec. 37.2 is 40, yes. 19.8, 20, that's easy enough. 40 times 20 is 800. Okay, but here's the bit you need to know. 0.36, about 0.4. Now, you can't round that anywhere, but that's 4 tenths. So if you're dividing, as you are, by a fraction, remember the rule? You change it to times and flip it. 10 over 4, look. And now you've got 10 over 4. You can now cancel, or an estimate of a cancel. 4s into 800 go 200. 200 times 10, 2,000. Done. But without that 4 tenths, you wouldn't make that happen, you see. So do make sure you get that decimal there, change it to a fraction. Remember, 4 is 4 tenths. That's all you've got to do. So it was 0.3, it'd be 3 tenths. Then flip it and do the cancelling. Okay, on we go. Another one of these. I think I've already asked this. A quarter to the naught is 1. You must know that anything to the naught is 1. Okay, now here's an interesting one. 3 to the y is 1 over 27, they said. Find y. You've got to recognise that 27 is underneath, and it's a power of 3. The underneath is minus, remember? So 3 to the minus 3 is 1 over 27. That's what they're asking. But so, of course, if now 3 to the y is 3 to the minus 3, these two coincide. And so y straight away is equal to minus 3, the powers. And then this one, another test of this silly thing. The minus means 1 over. The 3 underneath there means cube root of. And this will be a number we know. It's 5. 5 times 5 times 5 is 125. And then it's squared because of that. So 5 squared is 25. So it's 1 over 25 is what we need as our answer. And then finally, question 13 here. Okay, the question, another circle one. No angle mentioned at all, look, okay? But notice D is not here. D is somewhere in the middle here. But the important thing, as I've said earlier in this paper, is that look, here are the old two arrows again, which means there's parallels going on, and here's the old Z shape going on. Can't see an interior as it is. The Z shape is dead obvious there, so that's what's going to be asked. And here's isosceles coming on as well. So how do we do it? Well, again, you can read my script here, but what we do is as follows. Label these angles up. Let's put a B in there, an X in there, and a D in there. And what do we know? We know that B is the same as D. There's the Z there, look. So B is D alternate. But X is D now because this is isosceles. So these two are the same. So X is equal to D, base angles of isosceles. But since these two are equal, then it means these two are equal. And so, since those two are equal, we also know that ABC, look, is a semicircle. And that's one of our circle theorems. The angle in a semicircle is 90 degrees. So, B and X together makes 90. So, if you halve it, you get 45. And so, the angle we want, BDC, this one, angle D, is equal to 45. And there's our answer. Add your marks up, add a 90, and see how you get. 36%, our magic number, will be, well, there it is, look if you haven't seen it, 36% is about 32 marks. So see how you got on.